Hello and welcome to Penrice Transition Day. This is your science lesson with Mr. Borde and Mr. Round.
Thank you.
Your teacher should have had some equipment delivered to your classroom, which you will be using today. This lesson we're going to be looking at pH and acids and alkalis and indicators.
So what we'd like you to do first of all, please guys, is can you come up with a list, and you can either do this on your own or discuss it in your little table groups, of what skills you think is really important for scientists to have. So if you pause the video now, the teacher can pause the video now, and then try and come up with a list, discuss it as a whole group, what skills you think scientists should have. So some of the skills that we thought up were creativity, having good communication skills, observations, being patient. Some of the skills you can see on the slide that we've put for you, and there are loads more, so hopefully you came up with a really good list.
So as you can see today, our lesson is all going to be about acids and alkalis and something called the pH scale. And the pH scale that you can see on the board shows a range of colours from red all the way through to blue, and the numbers next to it run from 1 to 14. Below 7 is an acid. These are chemicals that can corrode metals and taste sour in our mouths. Above 7, we've got alkalis. These are chemicals that feel slimy or soapy as you touch them and can cause high pHs, cause burns and things like that. What we're going to do today is we're going to make our own indicator which will tell us whether or not a substance is acidic or if it's alkaline. And how we're going to do that is we're going to use a naturally coloured vegetable. This time we're going to go with a red cabbage, but you can use other things such as beetroot and even really brightly coloured flowers. How we make an indicator from this is that we chop it up as finely as we possibly can, place it in a vessel. You could use a saucepan at home, but at school we use obviously beakers, and you boil it up for approximately 5 minutes, and then you get a nice rich dark purpley colour like this. Now what we call this solution is neutral, because this is just water and red cabbage indicator, which means that the solution is not acid or alkali, it is a neutral solution. The pH scale that you can see on the board is for the indicator that we use in school, which is called universal indicator. You can see that at pH 7 we've got a green colour. That indicates that it is neutral. However, our homemade indicator is purple at neutral. So it's pH 7. If I was to put some universal indicator in here, this would turn green. But because it's this is your own indicator, it is purple as pH 7.
So before we start any sort of practical, it's really important when we're doing science practicals to think about the safety precautions. So things like making sure you're stood up, making sure you wash your hands after you use any sort of chemicals. Now, normally when you're in secondary school, you'll use safety goggles, which are massively important. For today, we're just using household chemicals, things like fairy liquid, things like bicarbonate soda. So you don't need any goggles for today's lesson. We don't actually have any left in school because we donated them to the hospitals, but we will have some by the time you guys come up in September.
Okay, now it's time for us to carry out our practical. Collect a dimple tray, and in this your teacher is going to squirt a drop of your indicator into 6 of your dimples. Once you have collected your dimple tray, go back to your table.
So each student will have a pipette like this, and once you've got your dimple tray, you can then collect a sample of one of the household chemicals using your own pipette so you don't cross-contaminate the chemicals. So I'm going with vinegar first of all. So simply squeeze the top of the pipette, place it into the vinegar, and then you just need to squeeze a few drops. Don't go over the top, just a few drops into your indicator. And then you'd simply repeat that for the other 5 household chemicals.
Before we start, we're going to remember that the neutral colour is purple, and that we're going to be using 2 common household chemicals that you should be familiar with. Vinegar, okay, which when I've dropped it into the pipette there, into the dimple tray, we can see that it's turned a nice pinky red colour away from the purple. And bicarb of soda, or bicarbonate of soda, which is baking powder, and if I drop that into the indicator, we can see that it's turned a very vivid green colour there. Now, have a discussion amongst yourselves. They are both not neutral. They've changed colour away from the purple. Can you think which one of those 2 liquids are acid and which one is alkali? And have a little discussion now. Pause the video. Can you work out what colour an acid has gone and what colour an alkali has turned? Okay. So some of you may have got the fact that vinegar tastes very, very sour. And so sour flavours usually mean that things are acidic, and vinegar is a very strong acid. And also
Ethanoic acid.
Ethanoic acid, indeed. And because it's turned pink, and that's the acidic colour, the other substance, bicarbonate of soda, has turned the indicator green, meaning that it must be the other chemical that we're working with today, an alkali. So the bicarb is an alkali. So alkalis will turn your indicator green, and acids will turn your indicator red, and anything that is neutral will remain the purple colour that you have of your indicator. Please work out the other substances that you've got in front of you, whether they're acid or alkali, and is there a difference between the colours that you see? Is there any that are particularly darker? Is there any that are particularly lighter? If it's darker, does that mean that the acid is stronger or weaker? If it's lighter, does that mean the alkali is stronger or weaker? Have a little think and a discussion, and note your ideas down on your table.
So whilst you're doing the practical today, it's important that you note down your results. So recording observations is one of those important skills we talked about at the beginning. And you have a table that you've been delivered. So on your table, you need to write down the name of each of the household chemicals you're going to be testing, the colour they go when they're put with the indicator, and whether you think they are acid or alkali. There are also then some questions at the bottom to discuss once you are done.
Okay, well done guys. Hopefully you've able to identify all of our chemicals today as acid, alkali and neutral, and that you've had some fun along the way. But one of the most important things we have here at Penrice is making sure that the workspace is clear and usable for the next people that come in. So clearing up is an important skill that you must develop. Today it's really important that you get rid of the chemicals properly and don't spill them. There is a grey bucket at the front of the class. If you come up one by one and pour the dimple tray into that grey bucket, and then place the pipettes inside the grey bucket as well, with the dimple trays on the side. If you then go back to your seats, if there's any spills that you need to wipe up, please use some blue paper, and then it's time to wash your hands. Hi guys, and now for the fun bit. Usually when you come in on the transition day, at the end of the lesson we spend some time getting out some of the fun, cool practicals that you get to see and be demonstrated to during your time at Penrice. Unfortunately, you can't do those live inside your primary schools. However, I hope you enjoyed the short video we've prepared of elephant's toothpaste, rainbow fizz, which actually is a neutralization reaction of acids and alkalis, and our methane bubbles.
It's a good one, that one.
It is a good one.
Yeah. So all that's left to say is thank you guys. Hope you've enjoyed the lesson, and we look forward to seeing you all in September.